Right, so step one. At step one, I'm going to say I'm looking for the what? For the circumference. Circumference. Okay, let me just say of the bigger diameter meter is equals to, you know, the formula for the circumference, isn't it? I'm going to say is pi diameter. So you know the value of pi, so the diameter of the bigger cycle, the diameter of the bigger cycle is what? Is what? Is a come back and record it is 70. So I'm going to say pi times 70. How much are you getting? So shift pi into 70. Yeah, how much are you getting? I'm getting 209,114. You understand? So you're going to say please use how much, because after the comma, the first digit after the comma is above 5. So we're going to say use 220, because this is 19, 220 millimeter. You understand? 220 millimeter. So in my step 2, I'm going to say step 2, the circumference of the smaller cycle. Of the smaller diameter. We're going to say is equals to pi diameter. So you know the value of pi diameter. Going to say so much is just 40, isn't it? 40. So if you simplify this one, 40, I'm getting how much? I'm getting 125.664. Therefore, please use 126 millimeter. You understand? You understand? So we were looking for the what? For the circumference of the bigger cycle and of the smaller cycle, the circumferences. And then from there we have to include the height now. Since we have to include the height, since our spiral is twisted, remember, since our spiral is what is twisted, we have to include the height. So the height that I'm talking about is which one? Is this one from here till there. Also remember, and they said this what is 90. So we have to include the height since our spiral is twisted. We are going to use the Pythagorean theorem. You understand? We are going to use the what? The Pythagorean theorem. So the Pythagorean theorem, we all know the Pythagorean theorem, isn't it? I can simply say R. Maybe I can say my step 3 is the Pythagorean theorem is R is equals to X plus Y, isn't it? Is into squared. So remember, it's into squared. So if I'm saying R, it is that one, it will be that value or that dimension that I'll be looking for at that particular moment. You understand? So I'll then say R is equals to square root of x squared plus y. I must then include my what? My h. This h stands for the what? For the height. So we must use the what? The Pythagorean theorem and include the what? The height, since our spiral is twisted. You can actually see it's a twist here. It's a twist here. You understand? So therefore, I'm going to calculate using this formula for the bigger cycle and using this formula for the smaller cycle. Why? Because now we have to include the what? The height. So I'm going to say of the bigger diameter. Let me, this one stands for diameter, isn't it? So I'm going to say x squared plus y squared plus my h, which is height. So I'm going to say, now I'm going to substitute my x with what? With that answer that I've gotten at my bigger diameter, the circumference of the bigger diameter, which is what? Which is 200 and what? Let me put it like that for now. But even if you round it off most, this is 220 squared plus your y is going to be 0 squared plus your what? Your height. Remember, your height is 90, so it's 90 millimeter, 90 squared, all under 1 square root. So the height is 90 millimeter. Is the one that you given. It's what? It's this one, my guy, from here till here. You get it? It's 90 because of, if you say 450 divided by 5, you are getting 90. You understand? So now if you substitute this one, so much 220 square root plus your y is going to remain as 0 plus your 90, which is the squared, is equals to so we are getting how much? 237.697 millimeter. Let me keep it like that for now. So this is what? This is the true length. Now this is going to be your true length of the bigger cycle. Understand? So this one is your true length. True length of your bigger cycle. Where's my rubber? Of the bigger cycle. So I'm going to show you where are you going to use this true length. You understand? So let me even not dimension it because of the space here. Let me limit my maths and put it up just a little bit up there. So remember, this was point number 1 where we are including the height. So at point number 3 now, we are going to use the Pythagorean theorem including the height. You understand? So we are going to say now of the what? Of the smaller diameter is equals to square root x squared minus y squared plus your height. Do not forget your height. You understand? So we are still going, we at the end we are going to confirm this graphically. We've been calculating it correctly or wrongly. You understand? Graphically we are going to prove that. So now after this one, we're going to say square root your x. Now we're going to substitute your x with what? With the smaller cycle. Remember, you said the smaller cycle. You understand? So the value of the smaller cycle was what? 126 squared. Your x, your y is going to be 0 squared plus your 90, which is what? Squared. And you understand? So you put this one into the calculator exactly the way it is. So I can just simply come in, most delete here and be like 126. You understand? So I'm getting 100 and how much? 154.842 millimeter. So you can say, therefore, please use how much? Use 155 millimeter, because after the comma is what? Is a it's a digit that is above 5, so 155 millimeter. You understand, right? Then from there you come back to your front view now. To your front view, I'll just extend this line just a little bit like this. Then now I place my drawing compass at this point. At this point. So just like an arc. That's going to be like this. Then this one is going to be R. Stand for the reference of these points that I'm about to get from there. I take it vertically up. So at that height, that point, I'm going to name it point M. Right, so I can extend this one, the bottom, like this. Right, so it's now getting interesting. Right, so along this line, what is going to happen? So I'm going to record 220 from point 0, 220 from point 0 along this line. Then do it. This 220 is for the what? Is for the bigger cycle. Is the answer that we got it here of the bigger cycle. So you place it like this. There is my 220, something very long. 210, there is my 220. You understand? There is my 220. So I mark there. So I can even dimension it like this. Dimension it like this. From here till here is 220 millimeter. You understand? So it's 220 millimeter. This 220 is for the circumference of the bigger cycle. Which one? That one that we calculated in our step 1. That one, 219.9114, which you rounded off to 220. So you record it from R, you get it there. Once you get to this point, you're going to take it to your median point. From here till there. You understand? So now we are proving what I was saying. We are going to graphically prove it. You understand? Can I have your attention? We recorded from here till there 220, which is what we calculated it there and it. Right? Then from here till here is what is the height of which is what we're given. So then if I record this dimension from this point where my 220 ends, including the height graphically, including the height which is from here till here, I must be getting what? They said I must. Why am I saying including the height graphically? Because mathematically we have included the height. So if I place my drawing, my 30 millimeter ruler from here till there, I must be getting 237. 237. And if we round it off here, it's supposed to say 200, because after the comma it's supposed to be say therefore use 238 millimeter. You get that? So mathematically we included the height. So now if I come and record this from here, from here till there, I must be getting that answer. Let's do it. There's my 0. 238. This is 230. This is 230. 235, 240, right? We are looking for 238. There is 238. We are absolutely correct. It shows that we are at a right track. So from here till here is what? Is 238. You understand? So my guy, that's how we go about it. of the bigger cycle. So now let's go to the smaller cycle. So the circumference of the smaller cycle, first we calculated it. We got how much? 126. So I remember, because it was 125.6. So round it off to 126. So from your point R, from point R, I record how much? 126. This is 130, 125. There is 126. You understand? I mark, and I can dimension as well. I can dimension it as well. Okay, my guy, from here till here is how much? Is a 126 millimeter. So in the final exam, that's how you do this, a spiral. So it's a disaster, I know. It's not something that you can just easily pass through it. So after that one, take this point to your median point. True length graphically. There you go. You get it. So if I record from here till there, I must be getting 115. Remember, mathematically when we were including the height, we got 115 millimeter. So now when I come and record from here till here, I must be getting 100 millimeter. Let's do it. Place it at point M. Exactly. This is 150, 155, 160. So there is at what? 155. You understand? This is absolutely correct. So this is 155 millimeter. You understand? So somebody might be like, why are you using graphical and mathematical? Assuming we stick on graphical, how were we going to get these ones? We were not going to, of course, the height way. So that is why we're given. That is why we had to calculate the circumferences first, and then we include the height. You get that? Then after that, we have to develop now. We have to develop now. How are we going to develop? Start here. At this space, my development I can see is going to fit here. At this space, you can simply draw a vertical constructional line. From that vertical constructional line, I come and place my drawing compass at my top view. I place it where, my guy? I place it at point A, further extended to point 0. Which is this one. Then I come somewhere here, I just place it here. Just go down a little bit. Just go down a little bit. Yes, yeah, here. Can place it here. Mark. So I have a point here. So this one I'm going to say this is A, this is 0. And I can construct it solid. I1. Then from there, what is going to happen now? We are going to look at what now? We are going to say the circumference of the bigger diameter. The circumference of the bigger diameter the one that it has got height. We are going to divide it by 12. The circumference of the bigger diameter. Which one? The circumference of the bigger diameter. That one. That one. So we're going to say the circumference of the bigger diameter, which is 220 divided by the 12. So the 12 of the bigger diameter, the 12 that I'm talking about is which one? Is this one. It's this one. So here I can say the circumference of the bigger diameter is equals to 220. This 220 is the one that we calculated there on it. Circumference of the bigger diameter divided by the 12 equal sides. So how much are you getting? Take your calculator. To 20 divided by 12. How much are you getting? So you are getting 18 point a point bring this 0, getting 18.333. So what do you do with that one? So you simply open your drawing canvas to 20, not 2018, which is what you got most. 18ish. I think I'm tired already. 18 there is my 18. So remember, of the bigger diameter, which means I'm going to place it at 0. If it was of this, place it at 0 because of the 0 is on my on the bigger diameter. If it was of the smaller, I was going to place it at at A, but I'm going to place it at at 0. Place it and draw a circle faint like this. Why are we doing this? Because we are looking for an apex point there. You understand? So that was step 1. So the circumference of the smaller circle. So circumference of the smaller diameter is equals to, we got how much? We got, go back, we got, which means if your answers are wrong right from step 1, it's going to be a disaster. So we got 126 divided by 12. 126 divided by 12. How much are you getting? So 126 divided by 12, getting 10.5 millimeter. Getting 10.5. So take your drawing compass to 10. You open it to 10.5. 10.5. So the 10.5 is going to be between 10 and 11. And now you can come and place it at what now? At A. And get that faint. Right, so from there we're going to join the circumferences. Just touch the circumferences of these two circles of yours. There you go. A line that it will just touch the circumferences cycle of yours. You understand? And then even this other side, do the same thing. Do the same thing. There you go. So where they are bisecting each other, that's going to be your apex point. That's going to be your apex point. So now you can place your drawing compass. This is my apex point. Take your drawing compass, place it at what now? At your apex point, further extended to what? 2.0. Faint, then you strike an arc. Strike an arc, faint like this. There you go. Then from there, take it, place it where? Along the circumference. Now, do you see that I have a point there? I have a point there. So now I can come and place it here. Further extended to 2.0. There you go. Then again I have a point there. Place it here. There you go. Again I have a point there. Place it there. Faint. another one there. So again, what you did this side, you are going to do it this other side. You understand? So there you go. There you go. There you go. There you go. Remember, we said there are 12. So there must be 6 this side, 6 this side. Let me see. 6, 5, 4, 3, 2, 1. So I must be getting a 0. So I can come back and place it here. That one, it should be 0.0. You get it? So 6, 7, 8, 9, 10, 11. Even if you'll be like 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. It should be still on the same thing. You understand? Even if you can be like kind of like repeating the same number, it should be. So back to 0.0. You understand? Then from there I can now have this one dark. No, before I even have that, take them to apex point. Very much important. This 0, apex point, 1, apex point, 2, all of them to my apex point, so that they don't automatically give me the inner cycle. Apex point, 4, apex point, 5's already there, 6 already there, 7 already there, 8, apex point, 9, apex point, 10. We go. Then 11, apex point, back to 0.0, apex point. There you go. Right. Then from there I can now have this one without fear or favor. Place it here. Further extend it. I now, which my development is going to start to be dark from here till there. Dark. Dark till here. You understand? Then of the smaller cycle, close it using the very same apex point further extended to your point A. So dark. Then you stop here. Dark. Then you stop at this. That is why it was necessary for you to take them to your apex point. This is quite interesting. So there you go, solidity. Yeah, 1. And solidity. Yeah, 1. So this is it. So thank you very much guys for watching. That was Mr. Kosi for engineering, for mechanical drawing as a whole. So remember, we started here from the top. We drew the top. Then after drawing the top, we had, let me give it just a little bit of a zoom. Is that clear? So they said construct the front. We constructed the front. Then after we constructed the front, then we had to graphically and mathematically calculate the true length, whereby we had to include the height.